What is the difference between a megabyte and a gigabyte? Find out at the end of this episode. Hello friends, Eli Hibbett here with the pwnyourhw Physics Series podcast. If you're looking to prepare, review, or gain an added edge or point of view about topics in physics, then look no further. Tune in each week to unlock your understanding of the physical world surrounding us. And now let's dive right in. Alright, how is everybody feeling today? I hope you're doing wonderful. I hope you're digging into physics as usual, and that today finds you well. My name is Eli Hibbett, your host of the Pwn Your Homework Physics Series podcast. And today, do we have an episode for you? This was actually the topic of today's episode, Powers of 10, was what I wanted to do for my very first podcast episode. But as I started to kind of lay out where I thought we could go topic-wise and kind of start building on things, I thought it would be better to cover the first couple of things that we dealt with. But I think that we have enough understanding that this is actually going to be a little more meaningful, having covered units of measure and kind of using powers of 10 to build on that. So first, let's start off with our inspirational quote of the day. Today it comes from Carl Sagan from the book Cosmos, and it is related to orders of magnitude and powers of 10. And he says, "The size and age of the cosmos are beyond ordinary human understanding. Lost somewhere between immensity and eternity is our tiny planetary home. In a cosmic perspective, most human concerns seem insignificant, even petty, and yet our species is young and curious and brave and shows much promise. In the last few millennia, we have made the most astonishing and unexpected discoveries about the cosmos and our place within it, explorations that are exhilarating to consider. They remind us that humans have evolved to wonder, that understanding is a joy, that knowledge is a prerequisite to survival. I believe our future depends on how well we understand this cosmos, in which we float like a mote of dust in the morning sky." So, having said that, I have a question for you. If you have 1 billion bytes, every computer, probably even the little device that you're listening to on this, has at least 1 billion bytes of memory. Or let's say you have a 30 billion byte hard drive. Do you really want to tell people, yeah, I got a 30 billion byte hard drive, I got a 250 billion byte hard drive? Well, we don't say that. And why don't we say that? Well, we say we have 250 gigs, 250 gigabytes, 30 gigabyte hard drive. It sounds nicer, and it gives you a little bit more perspective on it. You're not using these wildly large numbers. You can actually kind of reduce things down to a more manageable quantity for your brain to digest. I was taking a look at maps. I live on Long Island, but my hometown is Buffalo, New York, and the drive is 436 miles, which converts roughly to 701 kilometers. But right there, I just did it. I used a prefix of power of 10, kilometer. Would you rather say that the drive was 700,000 meters? Instead, we can use a kilo, which is a prefix that means 1,000, and say kilometer, and abbreviate it km. So what these prefixes do is actually modify the unit of measure that we're using. In this case, the prefix kilo modifies meter. And kilo means to multiply by 1,000, or 10 to the third, power of 10. And so what we can say instead is 1 kilometer. And then now it's 1, or 700 kilometers, and we're not really kind of exercising our brain too much, because we have a rough idea of what a kilometer is. So I would say, in lab or in class, mostly what you're going to discuss is somewhere in the order of magnitude of 10 to the minus 9 of 10 to the 9. So I'm going to try to go through here from memory what each of those are. 10 to the minus 9, prefix nano. 10 to the minus 6 is micro. 10 to the minus 3 is milli. 10 to the minus 2 is centi. 10 to the minus 1 is deci. Then going up, 10 to the first is deca. 10 to the second is hecto. 10 to the 3, kilo. 10 to the 6th, mega, and 10 to the 9th, giga. We actually have prefixes that go from 10 to the minus 24 to 10 to the 24, and I actually made a YouTube video that goes through all of those, so if you want to go that route, if you really want to dig in beyond that, check it out. But I would say for the most part, you're not really going to go beyond 10 to the minus 9, 10 to the 9, unless you're doing some crazy astrophysics where you're looking at unbelievably large numbers. Also, 2718productions.com has the full 10 to the minus 4 to 10 to the 24 list. So one thing that you'll notice is that a lot of the units of measure are given on human scales. Meter, kilogram, second are things that are in our human everyday time scale, things that make sense for us. And so something that I was mentioning on one of the previous podcasts is that measurement started out as a general ability to account for things that were happening in your human life. Like, how big is your house? How long is it? How tall is it? How many apples do you have? How heavy is it? How big an animal is? How much it weighs? How much meat there is? Or how long something takes. It's going to take you 2 days to travel from here to there. And so as we started to explore our universe and push beyond kind of human-sized issues, as we started to explore, with the invention of the microscope and the telescope, we could look much further and much smaller beyond what our eyes and human senses can process. And so we started looking at things like the megameter or the micrometer. We'd look into a microscope and see these very small animals. And so when you're dealing with things on these scales, you start wondering, okay, how do I measure this? And a bacterium is about 1 micrometer wide. And so you really want to say, it's 0.000006 meters. It doesn't really make sense. And so we started coming up with these prefixes. Like a 1 micrometer makes a lot more sense. It's 1 micrometer thick. The width of a human hair is also about 1 micrometer. And so these are actually really good things to gauge. Now you know, okay, a micrometer is about a human hair. So if you say 10 micrometers or 10 microns, you know what that is. You can kind of start to begin to feel that distance, even though and it'll be much more cumbersome to say, 0.00001, 10 micron. So, megameter, again, is the distance roughly from New York City to Chicago. So, between a micrometer, 1 human hair, and the distance from New York City to Chicago is 12 orders of magnitude, which is pretty incredible. Just kind of give you a sense of how much you can really achieve just by going, multiplying by 10 to the 12. So I have an app for this to give you a full review in the App Store. It's free. It's called Exploring Physics, Powers of 10. And there's a flashcard review from 10 to the minus 24 to 10 to the 24. And also has some, I guess what you call punny units of measure. Like 10 to the minus 6 phones is called what? Microphone. Or 10 to the 6 phones is called what? A megaphone. And my sense of humor doesn't really lend towards punny things, but going through those really helps to solidify things. When I think of micro or mega or that type of stuff, it helped lock it in for me very well. So if you can kind of make it fun and kind of make a joke out of it, it really does help. So if you're having a tough time, kind of go through those, and it will really kind of ease the pain for you, I think. One thing I'd like to not promote but tell you about today that I think is really interesting is there was this video made in 1977 called Powers of 10. And what it does is it takes this this guy and this girl, and they're laying on a picnic blanket. And what it does is it takes that picnic blanket, they say it's roughly 1 square meter, and they zoom out, and they zoom all the way out to the far reaches of the galaxy, as I think it's 10 to the 24. And they say this is the as far as we can visibly see as humans. And it's kind of interesting to see in the background after you zoom out past planet Earth. You wait till how long until you see any of the stars move. It's kind of unbelievable. I think you get to like 10 to the 8th or 10 to the 10th before they start moving. And then they zoom all the way back in, and they zoom into this guy's hand, and then they zoom all the way down to protons. And then it's kind of funny. You can see how kind of dated it is, that they speculate about the existence of quarks, and that they weren't really sure whether or not they existed yet. So I'm going to link that up on the blog, pwnyourhw.blogspot.com. Check it out. It's about 10 minutes long. It's really interesting. Again, it was made in the 70s, so it does look kind of dated, but I think it really holds up. So, yeah, I think that's going to wrap up our Powers of 10. If you have any comments, drop me a line at pwnyourhw.blogspot.com. If you want to reach out on Twitter, 2718 Productions. I'd love to hear what you're thinking, or if you have any questions, if anything you're running into, you just want an extra, anything on. Drop me a line. I'd love to hear what you're thinking. So with that, keep pushing the envelope, and I'll talk to you next time. Take care, guys. The difference between a megabyte and a gigabyte is that there are 1,000 megabytes in a gigabyte. The difference is a power of 10 to the third.